So yeah, this we just after GTC and everything, it was just so great meeting everybody there, and even for everybody that wasn't there, it was just like this whole global thing that was happening, and obviously, generative AI and LLMs and everything had been gaining steam for some time, and we've been working hard for a while, everybody, and just getting these to run on edge devices. But now it seems like we're getting to the point where they're quite optimized. We have them running good. We get like fast tokens a second, interactive latencies, ASR, TTS integration. And we just need to like take that more extra steps to get to that like cognitive AI, intelligent AI assistance, what everybody thinks of as something that make a smart home out of, or smart robot, or whatever you have in mind for your robot platform. This research group, we can all come together and basically focus on like the core inferencing, the core agents, and then you can take them and deploy them into whatever use case that you have for your business or your startup, your DIY project, or whatever it is. But I hope that in this group we can all come together and collaborate just to get like all the tools and infrastructure and models and everything that everybody needs, because it's all too much for any individual team or person to do. And I've just been keeping this list of like everything we need to work on to get there. And then everybody I met at GTC was like, oh, I'm like doing this or that. And like, great, let's like come together now and then to like get a plan of action, so we're all kind of like rowing in the same direction at least, and can support and leverage each other's work. So Brian, thanks for joining us. Great to see you again. All right, so let me screen share a little bit here. That's how we will drive this meeting. I'll just screen share things as we go through the notes. And I did post a bunch of notes yesterday, the forums, which is really good to capture just like where we're at and get that all in my head good. So we won't spend too much time going back over what happened at GTC, because that already a week, 2 weeks ago, it already feels like an eternity. Things move so fast, right? But just to like recap the most biggest impactful announcements that we came out with, there is this Project Groot and the announcement of the next gen Thor SoC for JETSON. So Groot is Jim Fan started this gear embodied agent research group at NVIDIA, and they have some cool results so far, like this Minecraft GPT agent that'll go around and explore the world and like learn things about it autonomously. And yes, that's just in Minecraft, but you can see how that robot brain could be put on like an actual robot. And then they did this cool like Ripper technology learning demo too with it. And they plan to train a foundational model for humanoid development over the next year. And essentially, this combined with Thor is what we are getting ready for. We need all of the like the model support, the infrastructure, our agent frameworks, all of that in order to be ready to accept this. And while Thor SoC is still like in design, there are interesting details about it that we released here, such as it's going to be an 800 teraflop module in the AGX form factor, and will be optimized for FP8 and for have 100 gigabit Ethernet. It's going to be an awesome step up from what AGX Orin is today. I think AGX Orin is at like 275 teraops today, and is also going to have a lot more memory on it. Even though like AGX Orin is an awesome board to work on with 64 gigs of memory, and that's what my main development platform is today. And then get that down to over Nano with SLMs and mini VLMs. And there's another blog on this about Isaac Ross integration with some more details there that you can find. But obviously, as time goes on, we will see this more and more integrated onto actual robot platforms, smart camera platforms, anything like in the edge. I feel most of them will use vision and multimodal, hence our focus on having the highest performance available. Because if you're just doing like text VLM chat, you don't need a gazillion tokens a second out of that. Llama.c++ is probably good. If you want to do real-time VLM, yes, you need like most optimized performance from it. And another research group that's been very impactful for our work is Song Han's team. He runs the MIT Hand Lab, and also works here at NVIDIA as well, and is on our research group page. And they've worked to train the VILA vision language model based on Llama, or based on Lava, and have many small versions of that for ORA Nano, and have done a lot of great work, not only in VILA trained on like a commercial data set, usually just literally using the Lava training scripts, and they also made AWQ and the Tiny Chat project. So there are some of these research teams that have been very, very impactful for us so far, that are like actually doing like the real work. Really what makes this all go around is like the silicon designers and these like high-end researchers that are doing like the foundational models and stuff. And then we take all of that and ingest it down and optimize it and deploy it to the edge, which there's like black magic there too. There's some dark art to that as well. But really like the model guys and the chip designers are the ones that are driving all this, and we like catch it up. Another group I wanted to give a shout out to, because they've been extremely helpful in helping us achieve what we've been able to do at the edge so far, is the CMU Catalyst group, who makes the MLC TVM project that we use for optimized inferencing. That's what we run currently on JETSON to get the max performance. And we'll discuss later when we talk about DevOps about how we're going to get TensorRT LLM as well. But if you're running like our containers or like the VLM stuff, that's all using this underneath to get the maximum performance out of it. Okay, so that's enough for like the recap. Let's just jump straight into the topics that we want to discuss, because that's going to take up like most of the time here. And while I did put a bunch of preliminary ones in here, all of these are actually quite important, and we will get to all of these at some point. In addition to other topics people want to work on together, please raise those anytime in like the forums or whatnot. I think a good format for this call going forward is if you want a project to be like on the agenda here for the meeting that we're going to dedicate like 10-15 minutes to discussing, create a forum topic for it, like I did for these other ones, with background info and some semblance of like a plan or rationale for like why we're doing all of this. Send it to me, and then I'll add it to the agenda for like the next meeting. But at any point during the call here, like later during the open Q&A, people feel free to say, oh, I have this need, or there's this like something I want to work on or investigate, and we can add that to this roadmap. All of this stuff is essentially to get us further into like higher level agents that have more interactivity, responsiveness. Like about a year ago, I set out to, I just want to make a LLM agent that essentially can learn who I am and my family, and put it in a little robot in the house, have us follow it around, interact with the HomeAssistant smart home system, and like make a robot that's like can learn to be your friend, essentially. But everybody has their own use case that they would end up deploying this for. So yeah, with that, the HomeAssistant one is a big ticket project that we've been wanting to like do this for years. Like Chitoku has one in his house. Brian, I know you have one. Shagazad has one. I think Michael from HomeAssistant team is joining us too. We've had discussions with them over the past couple of weeks about how to best go about this integration. Seed Studio is very involved with HomeAssistant because they make the HomeAssistant Green system that is turnkey and can actually run it. And we would love to be able to run the HomeAssistant on JETSON itself. And like HomeAssistant it's a very large project that on the customer user facing side, it's quite streamlined. It's just all web UI. You connect your smart sensors, set it all up through their system, and it's not that difficult to use. On the developer side, it is a complex containerized, supervised system that we wanted to ask them like how best to approach this. But basically what we're getting into here is this thing supports like thousands of different IoT sensors already out the box that we could never replicate. And they've also done like voice stuff and other integrations in the past, and are on a similar trajectory to us. They want to continue keep making these more intelligent, higher and higher level. And we want to basically improve the latency, interactivity, and responsiveness of this system by integrating JETSON for all the AI capabilities. And they have different APIs that they expose that we can hook into to provide our accelerated model support and things like that. It will essentially start off by using the same models that they have. For example, they have this Wyoming protocol that they define for, like, this is what the audio stream looks like. This is what the TTS and the ASR protocols look like. And we can use these like faster Whisper, Whisper.C++. We already have GPU enabled containers for those. It's just they're not completely optimized yet, or we haven't rebuilt them with the Wyoming thing. So that's essentially the first step in this project here, is just start off rebuilding their existing stuff on JETSON and then run an external HomeAssistant system on like their HomeAssistant system or on your x86 and point that to your JETSON as like this AI server that's running these Wyoming containers that we've rebuilt and enable with CUDA so that they're faster and gives you better latency of the system end to end. And I think the ones that we'll prioritize are Piper TTS, Faster Whisper, and Open Wakeboard, because those are the ones that we already know that should be working. And Mike from the HomeAssistant team, I don't know if he's on the call, but we've had some. Here. Oh, great. Thanks, Mike. So the streaming stuff is important in these, and he had pointed me to a PR just last night about I was digging into Piper, because in parallel, we also want to get faster and lighter weight ASR and TTS for Aura Nano. And because the Riva ones, while they are really good and fast, they consume a lot of memory. It's like 5 to 6 gigabytes of memory for just ASR and TTS. So that's kind of a non-starter on Aura Nano. And what we really like to achieve is having LLM, VLM, ASR, TTS, all running on Aura Nano 8 gigabyte in an affordable little package that anybody can take, very accessible, get started with Gen AI, cognitive voice agent, and deploy it in your home or robot or whatever. So being able to run all of that simultaneously on Aura Nano is important. And the streaming modes are this important too. But it seems like, Mike, we were just discussing this last night, there is preliminary support for this. And the Piper models, these are just like Onyx models that we should be able to run quite easily. I was looking at these on Hugging Face last night. So Mike, I did have a question of, these are all like the medium-sized models, which are actually still quite small based on what we're used to on JETSON. Are there large versions of these models available that sound even better?
There are a few large versions, especially for the English multi-speaker models,
Okay.
like the Libra TTS. But most of them are still
TTS.
on.
Okay.
Yeah, most of them are still on 22 kilohertz sample rates, so they don't sound that much better. They do get better cadence and stuff.
Okay. Yeah. Well, the cadence is important. The sample rate, sometimes the sample rate comes through and it's just fine because it goes through web audio and everything anyways. And like
exactly.
Sample rate, I'm less concerned. Yeah. And yeah, exactly. The speakers don't reflect that we're running at 48 kilohertz, but you definitely can tell a difference with 48 kilohertz versus 22. And so the model is actually bigger. It's not just the sample rate. Chris, what do you want to say, buddy?
Yeah, I was going to say, if you heard the Friday assistant that was running in my helmet, that's a Piper voice.
What? Okay. Yeah. And I was going through last night and playing some of these. Yeah,
that was the Scottish voice.
Okay. This one sounds good. The HFC female one.
Also check out Corey. That's the one I'm using. It's the
which one?
Corey. It's the British, English British.
Maybe so that's in a different.
So yeah, it's over in the English group.
The left. Pick the left.
You gotta change the English type to.
Oh, to Great Britain. Oh, I'll go through these too.
Go to Corey. then go to Corey. And then
Oh yeah, that doesn't sound bad. There are ones are in here that don't sound bad. And because I expected at such a small TTS model, it's not going to sound like a high-end transformer with like the cadence and everything. But I think some of these are actually past. Oh, and that's a high. Okay. Yeah.
There's a
All right,
medium
thanks,
one too I
Brian.
need to upload.
Yeah.
Yeah, check
Okay.
out.
there's a medium that sounds. Yeah,
All
the
right.
medium sounds
I
really
will
good.
check this. And so Mike, you're using Onyx models for this. How, and I haven't dug into the Piper code, but like how are you actually running inferencing? Are you using Onyx runtime?
Yeah, so these are PyTorch
Yeah.
models that are converted to Onyx.
Okay.
And the streaming mode it works through Onyx too, but it splits the transformer into encoder decoder. It needs them separate.
Yes, which is what we're used to seeing for
Okay.
streaming mode. Okay, so you just use this through Onyx runtime. I should just be able to enable the TensorRT backend for Onyx runtime, and this should be pretty straightforward to optimize. And it's not as if, yes, I can probably just run this onto JETSON today as is, and it'll run probably even using GPU just fine. But like if we want to really max the performance out and get that really low utilization, it's not even as if like I'm sure this will be above real time even at the high model, but if it could use 10% or less of GPU, that's great.
It's using very little on my platform. I actually did compile.
Okay.
I did compile Onyx for CUDA, and it's having no problems whatsoever.
And we have Microsoft actually gives us the wheels for CUDA and TensorRT. We will figure this out. And
Yeah.
This looks great. Okay.
I pulled the Onyx GPU down from JETSON's Zoo. I think it is. So it's on there.
Yeah. Okay. And we will give that. And again, anybody, I don't have time to spend on this for at least 2 weeks because as we're getting later, I'm still working on like build system, TensorRT, LLM stuff. So if anybody wants to like get this running with Onyx runtime on JETSON, sounds like you already have, but if you want to try the TRT backend and like profile the performance and say, hey, with the medium model, it runs at this real-time factor with this utilization, and the high model, it runs on this either on or Nano or AGX or on whatever you have. That would be awesome. And then if we could get a container for this into JETSON containers, it can be integrated throughout all of our stuff and automatically put in the CI/CD system so that everybody can just use it. So if anybody wants to take that up, that would be great. Chitoku has already started to look at, he's been working on the Whisper.C++ side of things to get a lighter weight ASR. The issue he's having right now is it uses like 100% GPU, and it is not as optimized. So yeah, we're gonna have to see about that.
I thought the Whisper, because I had compiled it here locally for some testing because I was going to replace the one that I was currently running, and I'm pretty sure they have CUDA optimization as well already.
They do. Yeah, and it's because it uses the GGML library that's used in Lambda C++, and you just compile it with like kublas enable and FP16 enabled, and we have that, and in JETSON containers we have what are all the ones we currently have? We have Riva, obviously, Fast for Whisper, Whisper X, XTTS I did for GTC, and that's another one of like the really large, slow ones that I'm not really going to be using much going forward. It might be that we use Riva ASR still with Piper, with a 3 billion parameter LLM. And that is small enough to get there. We'll have to see, because the Riva ASR is very low utilization as well. But we'll have to see. So yeah, Chitoku is working on the lightweight ASR side. If somebody did want to take up the flag on the Piper stuff, that would be great. And I would love to get this working too, because I also put a lot of work into Riva, and that gets to be like a headache after a while to keep up with everything. And Brian, as you know, like you've gone through all this as well, like what is our current de facto TTS implementation for JETSON, what's running best today. And I think if we have Riva and Piper, that will give us flexibility across the platforms at any. It's always good to have a backup for stuff.
Has anybody looked at K2, the successor to Caldi? I think they have CUDA acceleration.
Oh yeah, yeah. Caldi I've heard a lot about, and I know that the Riva guys use that.
So they have a whole collection of projects. I think Sherpa is like their something related to it. But I've run this before, and it has it does a pretty good job, and it's pretty low resource utilization, but might be an alternative. But I don't know.
All right. We'll check this out more. Do you happen to know if it does streaming?
I believe so. Yeah.
Okay.
Yeah, it's not like Whisper where you have to collect the entire audio and run it.
Yeah, and that's the big thing for us. We need streaming on both ends. Streaming on the ASR side because we want to be able to interrupt the bot, right, and like get that output intermediary. And on the TTS side, like our entire motivation is driven by lowering the time to first response latency of the system. In my experience, you need like a 1 to 1.5 second like query time back and forth to make it feel like a verbal conversation. I'm not talking about like speaking to your Alexa device and like all these. And I mean, obviously that's an issue with the HomeAssistant integration, that when it's run on smaller hardware for doing all the AI, you know, it's on par with like Alexa or systems on your phone. But we want a system that like you can literally have conversations with back and forth, just like a person, and that motivates us, drives everything really. But yeah, I'll look into the K2, and we want to support as many model types as possible. That's always been our whole thing. Martin, you had a question.
Is this your current system like real time?
The Llama speak that we do now is real time. It just consumes more memory than we would like using Riva ASR and TTS, and we want to bring that down to over Nano. But everything that we do here is geared for real time. And so we currently with the VLMs, we are at, where's my tabs here? With the VLMs, we're at like 1 FPS on Nano, or up to 3 on AGX Nano. And that might not seem like real time. Traditionally, I would like to say that's not, like 10 FPS is the threshold for traditional vision algorithms, right? Or 15 or 30 for full motion video. But in the case of the VLMs, they're so powerful and can convey so much information in that 3 FPS that it seems like good for a lot of applications. Obviously, if you're doing like a automated optical inspection in like a bottling plant where like things are like whizzing by or doing conveyor belts, then yes, 3 FPS is not enough for things that are traveling quickly, right? But for a lot of stuff in like people's static homes, this is totally fine. And as we'll talk about in the next topic with this controller LLM, the use cases for this kind of thing are like, hey, if you see the door open, ping me, or, you know, can you like follow me around on the robot? Or if you see the dog on the couch, tell it to get down, or, you know, other verbal queries that you can set. And you can see how that doesn't need to run at like 15 FPS. And even if it did run at 15 or 30, you would probably want to break that up into multiple streams. Because right now I have like a few Wi-Fi enabled RTSP mini cameras just around my house. And instead of just running one of them, I would want to run it on all 3 simultaneously at a lower rate, which is fine because the thing's so intelligent that it can pick things up like that. And as we'll see, the VILA models are also able to do multi-image at the same time, which we've not even really gotten into, and is one of the topics on here actually, is continuous multi-image streaming, because VILA can handle up to 8 images, whereas Lava can only handle 1. So we can set up this VLM streamings that it'll do up to 8 frames over a sampling rate of however you want. You could say, I literally want the last 8 frames from the camera, or I want a frame from every 5 seconds or every minute or whatever, and then you can do change detection on top of that. There is still some open questions in this about how to most efficiently do this with KV cache, so that you're not recomputing the whole KV cache every time, basically the whole context, because every image is 576 tokens if you're using the clip 336 image encoder. And if you want to redo all of those images, it takes a really long time. Like in this chart here, okay. So normally for VLM, we are at like 576 tokens. We use this as a proxy, right? So the prefill for one image is 300 milliseconds, okay, on AGX overrun. That means we're capped at like 3 FPS, right? Because that's the bottleneck. This is like the context prefill for the LLM before it even starts outputting stuff. Like if you see in the chat window when it does like ... when it's like thinking, it's processing your whole context. Well, what happens when you start having multiple images, like 8, you're up to full context length, then you're up to 3 seconds per image. So what we need to be able to efficiently do is just drop the last image off the KV cache and keep this rolling window of images going. The problem is LLMs are autoregressive, and you can't just chop off the KV cache like that, or you're not supposed to. But Song's team has this streaming LLM implementation that does some stuff. We're like reassembling the cache so that it like works good enough. And we have to apply techniques like that to the vision stuff. And I hope it's fine just like dropping off the last image, because we're just going to keep this continuous stream going, keep trucking the whole time. This is not for as detailed analytics as you would do over a previously captured video, where you're like, oh, hey, in this video clip from earlier today, how many boxes got moved in the warehouse or whatever. You know, this is more so of, hey, what's changed in the last 5 seconds from this video stream? And if there's aberrations in that or whatever, the last image is getting chopped off again next frame anyways. So like, let's just like keep it moving. Anyways, that's my hope for that. Like that just works. We don't really have time today to delve into this whole. This will be a topic for future meetings. But yes, today you can take the AWQ container and do multi-image stuff through it, and it's fun to mess around with. Okay, so quickly, our priority for this is to get this running and just to show JETSON integrated with Open HomeAssistant system. It should not be terribly difficult because we can just point it to our server. In the future, though, yes, we want to add Viva ASR TTS. We want to provide our optimized LLM APIs for their conversation agent API, which looks really simple. Just gives you text. You can run whatever NLP algorithm on it you want. Actually, it'll just be running TensorRT LLM or MLC or whatever model you want. They, like Mike and the HomeAssistant team, they're using Ollama a lot and ChatGPT integration. Ollama, I know, has been an increasing request in the community here, and I think they're getting closer with the Ollama maintainers to support that on JETSON. Ollama is written in Go, which like I don't know anything about Go or like trying to patch that, and Ollama is very friendly to use for new people, but it just uses llama.c++ underneath.
I think you can run on JETSON Nano Ollama.
I think there's a few people that have with like patches for it, but the thing is like the intersection of people that want to do Ollama, they're beginners, right? They're not comfortable with like diving into like patching the Docker file or whatnot, and the maintainers are still working on that.
So Dusty, I just to try it out, I did pull down Ollama on my AGX, and it works. It worked out of the box. So
did it? Okay, it is. All right, that's good. They've had it.
But you have to compile it from source, I think.
That's fine. That's fine. I can do it. I can do it then. I'm gonna make a note about that.
I know. I just actually pulled down.
Okay, I know, because before GTC there was a forum thread where like they were then working on GitHub issues with the Ollama guys to like get it enabled, and it was all stupid stuff. Like in their setup script, they were checking the platform architecture. And because llama.c++ we've had working for like a year and no problem. If it works out of the box, I will add a container to it for JETSON containers. And then that will be another avenue that we can easily integrate with HomeAssistant for, because they just support these Ollama models, and it won't be at the highest performance. Like the performance you can expect out of it will be about half of what that you'll get out of TensorRT LLM and MLC. Okay, because this is llama.c++, and this is actually up to 47 tokens a second now, and TRT LLM is just about the same. MLC is actually just a smidge faster for batch size 1 than TRT LLM, but we'll get into that later. Okay, that is very helpful info, Brian. I will add that. So that should be easy, low-hanging fruit for us to do. And then very excitingly, the HomeAssistant team they're going to expose more stuff to do, like vision language model queries and higher level things. And I hope that we all get heavily involved in that, so that as soon as those come out, be like, yo, we have all these high-end model types running on JETSON, or people like discrete GPU systems, whatever, and they can instantly take advantage of those. And I understand some people are less sensitive to running this in the cloud than others. I do not want any of my personal home data going into ChatGPT or any cloud system, like those Wi-Fi RTSP cameras I have. The only reason I would put those inside my own house is because I set up the streaming for them myself and blocked them on Wireshark. But like, you can understand why people don't want to have all of that stuff going back into the cloud. Okay, so just to round out on this, because this is actually a very important project, I feel, to getting AI into everyday life more. And obviously, like, we have not done this. The HomeAssistant team has taken this and ran with this. We just hope to make it more responsive, bring more intelligence to the system with these other higher level agents that we're doing, vision language models, like the whole thing. And also, like, I want to put this on a robot and then have the robot be able to tie into the system too. That's my like ultimate platform for this, which is this thing. When AGX01 first came out, we did this Orion project, which was doing some like basic Gen AI stuff. It was like kind of before that even came out. And I have one of these right over there. I've just not gotten to the point of like integrating it all together. But yeah, I want this thing like driving around my house and be able to say like, hey Llama, it's like cold. Can you turn up the temperature for me, or like whatever? And it'll just query the HomeAssistant system and go do it. The thing is, an external system like that, you don't actually want running your HomeAssistant. You want it to be able to pipe into the HomeAssistant. So they do have a very nice looking REST API that it looks like we can just pull all the data from that we need and be able to hook in external platforms, i.e. robots, into, and make this one cohesive multi-AI, multi-domain system out of. Okay.
I mentioned a little bit, I replied to your topic there. There are APIs specifically for voice satellite devices, so they can just stream in audio and get audio back and not have to do much else.
Okay.
You basically can set it up in HomeAssistant to do all the steps
okay.
of the voice.
Satellite. Is there ones for video, satellite video?
Haven't done any video yet, but that would be
okay. Well, then that is my overarching concern with this HomeAssistant integration is it's not quite as geared for latency as that's our like obsession, right? And I understand what like Paul is his obsession is making it easy for everybody to use. And like, yeah, I understand you're dealing with like general consumers that like this stuff is not easy, and being able to wrap it up in nice web UIs and predefined flows, that's what makes it all work. But things like what's the latency of the video stream, what's the HD encoding quality, like things like that, it might be for the vision stuff, we just pipe the camera directly into the JETSON and like it just outputs the video, but then I would like the video to show up in the HomeAssistant web UI too. So those are all things we'll have to play around with.
I was curious, what's the desire to pipe the actual audio or video across rather than just sending the API commands from the thing doing the ASR?
Well, typically we have the satellites are something very, very lightweight and small, like one of these little ESP boxes. So they're not running the ASR or even sometimes not even wake word locally. So that's the motivation. They're too small to do that. But you can run steps of the pipeline on your local device. You don't have to run it all on HomeAssistant. It's all modular. Okay. You can just run the intent recognition and handling if you want.
It seems like that's counter to the idea of having real-time conversations. For those small devices, it's more about just sending an audio clip and then processing that on hold.
Yeah, well, it's sending the audio stream, so it's not clip-based necessarily.
Oh, okay.
So,
okay.
But it is I agree, it's very much focused on this like Alexa-style interaction where you complete one thing and you're not having an ongoing conversation. You can have responses back, but we usually don't think of things like interruptions and that.
Yeah.
Okay.
Yeah. And I get that's like the status quo. And when really that was the whole reason I made that like Llama Speak with like my own web UI is I wanted to be able to talk to it back and forth and interrupt it and take it to like that next level over there. So hopefully we can all collaborate together to move from more of that like Alexa style device that you talk to as opposed to a more cognitive interactive one that you talk with. But okay, great. I do want to make sure that we can capture some actions from the discussion about this today because we want to move it forward. I know Seed is also going to be looking at running the whole HomeAssistant on the JETSON itself. They have experience with HomeAssistant Supervisor, which is the system that like orchestrates all their containers and everything. Oh, Mike, you replied to the thread. Thank you. Yeah. This is great. Sure. And this is the type of back and forth we want to have, as opposed to like emailing each other about these things. Let's move all the discussion to like the forums or GitHub issues or whatever, as long as people can find it and stay involved and like contribute and provide feedback or testing. And we want to be able to look back later and find all these details that aren't buried in some Slack messages or Outlook later. So yeah, this is and you have WebSocket API. Great. Okay, I use like WebSockets for everything pretty much. And there is also a quick discussion to be had about what are the actual like we need an actual like user interface device for these things. Like Willow has it's like an ESP32 type thing, and I saw this on your website.
Yeah, that's what I showed.
Yeah, you have. Okay. Yeah. Well, tell me, do you like that thing?
It's okay. The speaker's crap on it.
Okay.
The mics work surprisingly well.
Okay.
We are working on our own device too.
Really?
I will say, I will say you can get a long ways with I don't have any here, but with these cheap little microphones and stuff. So they don't work as well like long distance, but.
Oh yeah, and that's not to be expected. I think it's either Seed or SparkFun. They make the Re speaker, which is like an array, and like those things are really good, but they're also like $100. And I know from talking with Seed, they also have like a little mini camera with a microphone and a speaker, and like we want something that's cheap that you can put in like most of your rooms, or because if you don't have that robot driving around, you need these little client devices in every room essentially to talk to. And so does this ESP box have a camera?
No.
I don't think so. Yeah, we need one that does camera, mic, and audio, and ideally a little screen.
Yeah, I'm not sure of one that would be based on an ESP. Probably a Pi.
Or we don't care what it's based on actually, as long as it's affordable, easy to use, has good audio and video quality, and Wi-Fi streaming, and like. But we want to be able to support like all these, and actually, it's not even if we do this HomeAssistant integration right, it's not even our problem. Actually, it's just more of an issue of like once we turn people onto this, for people that are new to HomeAssistant, like I am. Actually, like what are the little sensor packages that they get for the user interface? I know that you can get like the smart thermostats and smart light bulbs and like all that stuff. But I'm talking about what am I going to be speaking to, and stuff like this. So what other ones of these do you have now that you like?
So, I mean, for super cheap ones, this little M5 Atom Echo development kit, it's a tiny ESP device, even worse speaker, but it's like $13.
Okay. Yeah, all that stuff is okay. Are there any others?
Yeah, so if you look for a Wyoming satellite, you'll see we have this is a software implementation of a satellite for HomeAssistant, but the main thing people use on this is a Raspberry Pi,
with the re-speaker mic hat.
Yeah, so these are the two mic hats, decent, fairly cheap, maybe $15-$20, and then you get a Pi Zero 2W.
That's cool because in theory, we should be compatible with this on over Nano because we have the same 40-pin GPIO header as Raspberry Pi. Now, if the pin mux is set up the same or not, that's TBD. But like, in theory, it could all work. Okay. Okay. Cool.
And it looks like Seed's working on other stuff too that'll be coming that will be even better.
Yeah. I don't know if you're involved with them in the conversation about that, but it seems like they're making some little device. Then I think this one has a camera in it, like ESP32 cam. And obviously, since like if you're not doing vision, JETSON is like predominantly vision based because like everybody's doing cameras on it, right? So like we're obviously interested in devices that have the cameras in there, and is also a big part of like running it locally because if I feel people are more comfortable with having cameras in their house or outside in their near vicinity if they know that data is not going to the cloud. And this can be like a Nest smart door cam that you can program yourself and change around all the queries and event triggers and everything. Okay, let's move on quickly, and we'll give a couple more minutes. Anybody want to have any closing thoughts about this?
Yeah, Mike, just a quick question. Should we also cover those devices like conference mics? Here is the, for example, Anker PowerConf.
I have the same one. Yeah, that's what I use.
It's a pretty cheap device. You can connect it through the USB and just use it. It also works with satellites. And
I think it does Bluetooth. Yeah.
I think so. Yeah.
And I don't think like that is not like we shouldn't even have to like touch that support really. That should just work out of the box with HomeAssistant is my understanding, which is like a big positive. That's why we're doing all this is to leverage everything that already works with HomeAssistant.
Yeah, pretty much. And so that's you mentioned integration. So the nomenclature of heavy HomeAssistant user, in most cases, it means like a plugin for HomeAssistant. So Mike, do you think we can approach what is the best direction to practically integrate that by using APIs or a dedicated integration like a plugin for HomeAssistant?
Well, I in the reply to the thread, I talked a little bit about. I think if you implement the Wyoming stuff, it's pretty lightweight, and you'll get a big bang for your buck for that, just because you can plug it in immediately. You can use the APIs, but I think the integration, if you have very custom things that you need to do, like if it's just you stream in audio and the user sets up everything on the JETSON beforehand, then there's really no need to have a lot of customization there.
I just saw you already replied with a PR for doing CUDA in all the Wyoming containers. Wow.
Yeah, people have been working on this. I have to get back to.
No, I get it, and hopefully we can jump in and help too. And sometimes there is even a little more specific support for JETSON, but this is so we'll like change this base image to like our JETSON CUDA base image and Onyx runtime GPU. Okay, we should just be able to make this work.
To do for Piper.
Okay, cool. No, that's awesome. And then we can just integrate this into our JETSON containers build system so that these Docker images are already automatically built and pushed, and people don't have to build them themselves even. Cool. Well, I would say this is definitely a concrete action to come out of this convo that like we need to go off and try this PR. We need to try your PR for the streaming Piper, and Chitoku is working on Whisper.C++. And I think those three are probably enough for us to bite off just to start here. Please, anybody that wants to help with this project, feel free to jump in on any of this, hop in on the forum thread here and say what you want to work on, what you're doing, link to GitHub commits or like whatever, because this is a big project and I don't think any one individual is going to be able to bite off the whole thing. But yeah, I'm especially excited for this Piper TTS. So
can I make a small pitch regarding that?
Yeah, go for it.
I just want to say that the company behind HomeAssistant and Abukasa, we collect public domain audio data sets for Piper to train public domain voices. And we're trying to do this for non-English, languages, especially ones that have low resources. So if people are willing to donate their voices for that, it's like a couple hours of recording, and we will even pay for studio time where you're at to do that. So.
Oh. Well, Chitoku is fluent in Japanese, so maybe he can help you out.
That would be awesome.
That is great though, and those type of community-driven models are super important in open source. And we didn't even really get into that whole thing about this group at the beginning of the meeting here, but this all being driven by open source in a transparent, accessible way is super important today, just because of like everything transpiring with, is there going to be more regulation on open source, or like how is this all going? So that was a big part of why I wanted to make this in our formal, informal research group here, so that everybody can just feel free to come and join us and work together in a completely open fashion, train the models, and everybody knows what we're doing. There's nothing to hide, and everybody can benefit from it. Okay, now that we spent most of the meeting, I had no idea how long this meeting was actually going to take. I figured it would be definitely more than an hour. Maybe future ones will be able to cruise through status updates more quickly. The next major topic is this controller LLM. And the notion of that is there needs to be a higher level model that sits on top of the system, directly interfaces with the user, and retasks the lower level expert model pipelines. And essentially it's because we found that when you're chatting with the vision language model about images, it no longer has the ability to be very conversational. It actually does. If you don't give it any image, it sounds just like Llama. And Llama is a very cute conversational model. It'll chat you up all day. It's fun to talk to. But as soon as you give it an image, it will then like basically only want to talk about that image. And I believe the reason that is because the images are 576 tokens and your input is only like 10 or 15 tokens. So it's like overwhelmed by that. And you might be able to fine tune your way out of it. And that's a bigger thing here, like Jim Fan doing his, embodied agent foundational omnimodal model that does everything in it. We might not even need ASR and TTS because like it's just going to do everything inside the model. We'll see if that's what happens here. For now, we will be working with all these different models independently and do prompt engineer our way out of this, essentially. But what it actually all boils down to is this function calling capability, which OpenAI refers to it as these tools, right? And I'd done some initial experimentation with this some months ago just to see if like this was possible with Llama. And where is that slide in here? Sorry, let me find it for you. It's this one. Okay. So basically you just like, this was just an Ooga Booga that I tried this just to make sure if I could replicate this like tool capability myself through Llama 7B. You just put in the system prompt, these functions that it has available, and say, hey, if the user asks what time it is, or asks something that you don't know, or wants the weather, or wants to call into the Home Assistant, or ask you to drive the robot, or whatever functions you define specific to your application, it should then be able to call that. So I told it, hey, you have this weather function, and then asked it, what's the weather? It spit out this code in backticks so that we can parse it out. And then, and we just need to integrate at the generation, the low text generation level, looking for JSON or Python code that it outputs, run that code, and then inject the result back in to the chat and have it continue generation after that. So it can then utilize that information. For example, if you ask it, what's the current temperature out, and it injects that result back in, it can then converse about that current temperature without needing to go through a whole other generation stage of it. The thing is, this is very much akin to like the guardrails guidance topic that's also listed here on the page. This one, guidance, grammars, and guardrails. The grammars is essentially for doing like constrained JSON output so that it doesn't, you can keep it on track with like all the keys and stuff that you want in the JSON for it. But this all happens at like the token generation level inside the lower level LLM APIs, which is one reason we like work with those directly, so I can like get down into like the weeds of doing, like Michael, you were talking about how you split the TTS and doing encode and decode separately, and by virtue of being able to do that, you can implement more features like streaming. Well, when we split the LLM into the prefill and decode stages, we're also able to do more advanced token manipulation, token healing, and integration of like these plugins and things like that. So once we get that, then it should just be as simple as saying, hey, LLM, you have this, video query plugin that you can call that will change the video query that's being currently run. Or you have this reconfigure pipeline call that you can spit out the JSON of like the entire pipeline if you want. And we want to use like Code Llama for this, or something that has better coding abilities. And I think like this example here, just showing with like these simple Python calls, because that was like really easy to get working. But once you start doing parameters to these, you want it to be in JSON, because it will keep the parameter arguments straight that way. The only downside to JSON is that it's a lot more tokens, and you can also see that an issue in this example here with like this you can have the VLM output JSON too, which is another avenue for us to explore, rather than just having the LLM output text and then us like doing rudimentary filtering of that text to trigger events. It can just output the JSON. The thing is, every bracket and comma and stuff is an extra token, and numbers are all extra tokens, every digit. So it slows it down. This is like 128 tokens or whatever, and it means it takes longer and runs slower to output JSON. So that's something that we're going to have to overcome. But I did talk like Akash and Gary from Robotniks. I don't know if you guys are on the call, but they did do some like experiments with architectures like this, and said it worked quite well for them. Basically having this higher level LLM, and it might even be able to share weights.
I'm here, Justin. Hello.
Oh, great.
Hi, this is Gary. Hi, guys. I have no video stream. I'm sorry. I'm in the car, but I listen. I can hear you all.
Wonderful.
From Germany.
Thank you. So Gary is one of our long-term partners from Robotniks. He's always been an early adopter of like this awesome stuff. And we were talking about at GTC for months. He's actually been fine-tuning his own controller LLM model for doing like advanced agents in video analytics and all types of stuff. And it seemed like his results were very, very encouraging from doing this. I don't know, Gary, if you wanted to speak to your experience with this real briefly, that would be great.
Yeah, sure. I listen very carefully. As you know, I'm also focused on all JETSON platform, not only on the smaller ones, also the bigger ones. And it figure out that the JETSON, the big one with the AGX 64 gigabytes, is perfect for huge, large models like the Mistral open source that normally requires 2 H100 cards, right? Because the high number of gigabytes.
A lot of people seem to like the Mixtral MOE.
Yeah, the Mixtral.
I get a lot of requests for that, actually.
Yeah. And I fine-tuned this in a 4 or 6 days session to 6-bit with the GUF format that is Llama able to do.
Llama C++.
And as someone said before some minutes ago, that it's possible to recompile from source, and it was just 5 minutes to cross-compile it to the ARM architecture, and then I load the model and I took out the memory 20 gigabytes, 25 and 31, and then it stopped and then it executed. And they said, what's going on? It gives me 50 tokens per second out of this edge device.
Okay.
Amazing,
is that that's with Mistral 7B?
7B8, right? It's an 42 billion model that you can execute on the agents.
With Llama.C++, that's not bad.
Exactly.
Okay. Well, and you know, for all the Llama.C++ users out there, I've noticed Llama.C++ Python has a lot of overhead to it, unfortunately.
Yeah, right.
I don't know why.
The right is because it goes to the interpreter session and it copied the tokens to the interpreter session and then print it out. And what they did in the code is something like slow to make it type and write, and there's some delay in it. So it's better to use the native C++ engine and then to pass it to JSON and then maybe to run it. It's much faster.
But I'll say, even so, like if you're going through the trouble of integrating with Llama.C++, just use we'll talk about it in a second. We have this thing. It's called the local LLM container, or now it's called NanoLLM, and that is Python. But it does much more optimized stuff through MLC and now XRT LLM. And like just save yourself a favor and do that, because it will be faster than Llama.C++ is anyways. But I think and so the results of it seem to be quite effective for you running this like controller LLM to you said you were using with ALVIT, right?
Yeah. And there's another engine, Dustin, I don't know, it's called Wasm Edge. You know this? Wasm Edge?
Wasm Edge, yes. Okay, we should invite those guys to this group too. I've heard of that, yeah.
The difference is that you have a single session on the Llama because it blocks this the whole time when it's get back the tokens, but the Wasm Edge can have several parallel questions, and that is of course slower, but if you want to, as we use it for our employees with 4 people at the same time for internal answer and question, the Wasm engine is much better for parallel questions.
You're totally right. And that was another thing. While like when I started using MLC to get that 50 tokens a second, it was also single user. So I basically dropped their API, wrote my own, did very low level token generation stuff, which is now how we'll be able to do token healing and grammars and function calling and everything. But I was able to get much higher perf out of it and do multi-user stuff, because really it's just the KV cache you got to keep. You have to cache the KV cache. And then you can run as many as you want.
I'm so excited to share this information with you guys, because you understand.
That's great. And also, like, we might even be able to share the weights. Like, this might not. You have yours fine-tuned, hopefully, which speaks to like it actually works really, really well in production for you. But I think it might even be like we can use the same VLM weights. It's just a different chat session where there's no image in it, and it should then resume to being like a normal LLM and be able to talk to you. And that'll be good for over Nano.
And Dustin, maybe one I think important information. I test the new FP8 performance on the L40S card, which has the acceleration and gives you right out of the box with the cache enabled 20% more tokens. And that means the new Thor architecture, which also have this acceleration, will give us also the performance with this cache acceleration. So only for
that is very interesting. And if you know the delta of what it is on L40S on versus off, that should allow us to estimate the performance speed up we'll get from that.
That's what I want to say. And by a much lower powering, right? So I don't know the powering of Thor, but I'm pretty sure it's not
with Thor. This is all we're at that 3 FPS right now on the VLM. We're gonna be at like 30 on
I
Thor.
hope so.
It will be like real, and then like, yeah, it's gonna get really wild then.
Yeah.
Because it's gonna be spitting out stuff so fast you can't even. Yeah, it's.
And maybe we can train on this, right? We can train data on this.
That is a discussion topic that's in here. I don't think we necessarily have time to like really delve into this during the call today. Okay. But like anybody that wants to go out and try this on an AGX over 64 gigabyte, let us know if it works. You can, like the VILA team at NVIDIA, they literally just used the Lava training scripts. There was the booth demo next to us at GTC. That guy, Neil, he's on the IGX team. He had trained his own Lava and fine-tuned it. He said it's not difficult. You can make just a real simple test data, like a yes, no. Like, hey, should I sort this object this way or that way? Yes or no, left or right? Like do real basic tests. See if you can train it on the AGX or on 64 gigabyte or fine-tune any other LLM. I think it'll work because people fine-tune and do LoRa's all the time just through Ooga Booga, you know, and on like their 3080 or 4090 cards. So it might run slow, but I think it'll work just fine. And yes, it's not for production, but like we can then make a tutorial about it here in the JETSON AI lab. And I feel like that will do a lot to satisfy people's questions about, because people want to be able to have the whole workflow down, right? They get the pre-trained model weights from like Meta or Google or whoever. Then they need to like fine tune it, deploy it to JETSON, put it on their device. That whole flow needs to be complete for them in order for this to be viable system to go into production with people. But yeah, no, this like we're gonna have to get into fine tuning these at some point, and I feel like we'll be an essential part of this. So the actions to come out of this, and so I put myself on this one because it is a low-level feature that I need to implement in our text generation APIs for doing this plugin function calling. And really, it's just like this sampler interface, kind of like Hugging Face has, but we'll just have a similar one that it'll be able to either do grammars, guidance, guardrails, function calling, stuff that's in line with the token generation and not done after, because you don't want to. Our token generation is always done asynchronously today, where like you're reading those tokens from another thread while it's still running. Well, all of this stuff you would want to have inside the LLM thread itself for consistency. And there's a whole lot of like KV cache manipulation that can go here. Like you call the function and then you backtrack its call of that function and remove it from the chat so that going forward it's not in there, and like all kinds of stuff. But we'll get to this is actually high on my priority list to integrate because this is what will the Home Assistant integration is very important for basically IO, okay, and like integrating into real world system. This controller LLM is what should get us to like a more cognitive, higher level thing that can interface based directly on your feedback, change around its behavior. This will also have calls to the vector database and RAG system. So I want to be able to task the system prompt like, hey, you're a friendly virtual AI assistant that wants to learn about the user. And if they give you any personal details, like their name or their schedule or things that are happening in their lives, record those into the RAG system and then be able to query it later so that when you come back later, be like, hey, Llama, how are you? It's like, oh, Dusty, great to see you again. How was your meeting earlier? Did that go well? And like things like they can just like have a higher level of being able to like add its own tags into the vector database and retrieve that later and create this like self-fulfilling workflow of keeping up with all of your latest personal data. Not that we're going to this extent of having like a literal co-pilot virtual assistant like would be on your phone that's really managing your like day-to-day life, but more so like this is your friend and like keeps track of you. Or you can use this in all types of applications for one-shot, zero-shot RAG learning, which the basics you can see of in my latest VLM videos in that demo, where like, hey, it doesn't recognize something, you can just tag it in. And right now that tagging is done manually, but via these plugins, it should just be able to tag things itself and learn things itself. And that vector database is essentially just the hippocampus or the long-term memory Yeah, Mike.
Yeah, there been any work combining like this function calling stuff with RAG itself so that the functions like can be dynamically learned?
That's a good question. And there's no reason why not. Like RAG, I'm gonna note that down. Yeah, like RAG can just do the system prompt. Like
so the reasoning here is, from my perspective, HomeAssistant has many different service calls, and to dump them all into a prompt,
it's too long.
Do you
I'll kill my
and
memory.
So
yeah,
you kind of I mean, you could either have a function to get functions, or you could have it learn like just a particular context.
Yeah,
like
that did occur to me that like we're going to start off basic here, but eventually we'll get so many functions, there's too many for the context, and we're going to end up chewing up a lot of context just for all these function definitions. Like, okay, so we have 4096 tokens, and that's only models. New models are keep getting longer and longer long context, right? But like we could use half just for these function definitions, which I think is fine, because like you don't, who's doing chats that long every time with the agent? And like after 1024 tokens, you can run one of these functions can be summarized. It'll summarize it and then put it in the RAG, and it'll remember your conversation from later. And but yeah, RAG to make system prompt. That's yes, we will do that, and that will not be difficult to implement, because it's just at the system prompt level. And RAG in general is really not difficult to do now that we have all those bits and pieces in there. And it's also because we're using the multimodal embeddings, which they're very powerful, and we're using the high-end clip model to do it, and it just like works like magic, as opposed to a lot of like the enterprise guys are using the smaller sentence transformers, because they're like they're doing like millions, billions of queries against these systems on very complex like reams of PDF documents and stuff, that they're working on internet scale size data, right? We have the benefit of, even though we have, a terabyte of models on our NVMe and whatever, our data set sizes are still manageable, limited to like your personal life or factory floor, like whatever. We've not yet gotten into like that huge. For example, with the vector database right now, I use Spice for their similarity search kernel, so it's very, very fast. But I'm just using a flat index and actually doing my own indexing, because I found with Spice, it's very, very slow to add new things to the database, because it goes through and re-indexes things, and it takes forever. It breaks the real-timeness of the system. So I just do a flat index of, like, in the case of the MS Coco, 350,000 embeddings, and no problem. It works super fast. And for things of that scale, like 1 million images or text entries or whatever, I'm sure at some point we'll have to revisit this once you start like recording your entire life into it or whatnot. But it's fine for now, and shouldn't be an issue. But yeah, once we keep adding more and more functions, it will then, you want to take the prompt that the user says, use RAG to find the relevant functions to that, and then only inject those functions, which could also help steer the LLM to what you actually wanted to do. And I feel we should use mostly JSON for this. There still should be some like parsing of that, manually hooking up. Obviously, we can get into like Python code interpreters in a sandboxed environment, but the implications of this being on like a real embedded system running its own code that the LLM generated on like a robot, all of that aside, the JSON seems to work much better with just keeping the order of the parameters straight once these plugins start getting more complicated. Okay, last major topic today. This is actually a big one, because it's all of the ML DevOps stuff and what makes this all really go around, being able to build you know, gigabytes and gigabytes of this high-end inferencing code and all the models and all these open source packages, and just being able to make that all work is a small miracle. And Mosaico has contributed a lot of PRs recently to JETSON containers for this, which I really appreciated. And so there's a lot of initiatives in here that have a lot of downstream impacts that JETSON team has been working on for years, which, as I'm sure many of you have known and been frustrated with, Jetpack for a while has been like a set configuration, right? It comes with the CUDA, you stick with that CUDA, new Jetpack comes out in 6 months, you get a new CUDA. Well, obviously we want things to be much more like normal system, an x86 PC or whatever, where you can just go pull the latest CUDA. Well, now you can do that because in Jetpack 6, we've done a whole bunch of stuff with decoupling all the Tegra patches out of the kernel, doing kernel module drivers for the GPU, much more like a traditional system, still using integrated GPU with like user space CUDA. The difference always was that like with JETSON and iGPU, all the driver stuff could be in user space because it's just shared CPU, GPU memory. It can just be M-mapped. You don't need kernel level ioctls and stuff for calling CUDA kernels or anything because it's all just there in the same memory space. Versus discrete GPU, it is different because you have PCI Express or NVLink or whatever involved, and those driver architectures were different. Well, it's been years of effort under the covers by all these like many engineering teams at NVIDIA, but we've like unified that into one driver model and continue to do so. So long story short, now you can just download, you can go today and download CUDA 12.4 and install it on top of Jetpack 6, which normally comes with CUDA 12.2. And when the Jetpack 6 GA comes out in a couple of weeks, I believe that still has CUDA 12.2 because what Jetpack is moving towards is like a 6-month formally supported snapshot of like our production tested, been through weeks of SQA and like all this stuff. And but you'll still be able to install like latest CUDA. Then the issue is that, okay, great, you got CUDA, cuDNN, TensorRT latest. There's still a huge stack after that to compile, including PyTorch, Torch Vision, MLC, all our APIs we use. If you do this all manually by yourself, it will probably literally take you a week just to like do it, come back 6 hours later after PyTorch builds, installs, test that. So basically I modified JETSON containers so that you could set the CUDA version that you want. Sorry, let me start sharing my screen again. I thought that it was. Hopefully this doesn't crash me again. All right, so I modified the JETSON containers so that it will rebuild against any CUDA and build the whole stack thereafter for you. And the issue that I was having initially with this is my build farm can only take so much. And once you start combining all these, the number of container builds explodes out of it. And I needed some other way to manage all this. So now we have our own pip server that caches all of these outputs from the system, like here. So I'm trying to see like this little page. This is like a DevPy server that I'm running on one of my JETSONs here. And now you can just go on and download all the pip wheels that JETSON Containers builds. And these are only like the problem children, okay? These are all the ones that require like the patches and take like half an hour to compile or hours. And these are the ones that really slow down your builds and everything. And so now you don't even have to use containers if you don't want to. I still recommend it so you're not blowing up your dev environment all the time and can keep things straight and tested and all that. But like you can just go on and pip install Torch Vision and it just magically works now. Or you can pip install transformers and that magically works too, because it will transitively install the correct version from my PyPy server. So I hope this makes the whole development experience a lot smoother. on JETSON, because that's been an issue that like you can't just pip install stuff. And even if you do install our PyTorch wheel, if you go then install another package like YOLOV or Ultralytics, it'll uninstall the wheel you just installed and install the newer version from PyPy. And that PyTorch wasn't built with GPU, so it doesn't work. It all just works. I had to patch the DevPy server to like blacklist stuff and but it open source for the win, right? And it all just works magically right now. You guys are free to start messing around with this, test it. Let me know if you have issues with it. I would appreciate some like beta testing on this before we roll it into like this being hosted on nvidia.com and get the software teams go ahead for that. Okay, one more thing. The local LLM container that I had been using for everything, it was getting too big to have just in JETSON containers. So I moved that to its own repo here, renamed it NanoLLM. Sorry, but it's consistent with like all of our other libraries that we have. And importantly, made like nice documentation around it and like the APIs and like this is like the model generation API. It's very much just like Hugging Face is. It's like optimized Hugging. I think of like Hugging Face. It's like OpenCV. It supports like every algorithm. It's terrible with memory allocation and like it's not optimized. It's slow. Hugging Face, you're gonna get 5 tokens a second versus 50, right? That's where we start. We started at 5, and we got 10x with this. But it has all the same parameters and everything in it. And there's multiple levels to this. You can just use the low level text generation. And it's fully multimodal. If you load a vision language model into this, it'll load clip and the projector and handle all the embeddings and all that stuff for you underneath the covers in an optimized way, that's how I do like the live streaming. Everything has been to get that. And then there's like chat APIs built on top of this with like templating. And this chat history is actually very important because that is what keeps the KV cache, and inter-request KV caching is so that you're not continually doing that pre-fill every time, which is essential. And also, as Gary was mentioning, this is how you run multiple chat sessions simultaneously against the same model. And this is an unstructured, multi-turn, multi-user, multimodal chat where you can like add any media to it from any role, and it'll like template it based on what the model's capable of doing. And it's essentially you put in text images into it, and like this here, you like append your text, or this message can be an image, text, someday audio, or like we're going to move to using image bind for the embeddings, and that does point clouds and IMUs and like all other types of sensors. And these chat messages will support any data type that has an embedding defined for it in the embedding model. And this just spits out instead of giving you like, most people when they think of, oh, I'm working at like the token level, we work at the embedding level because we're doing multimodal, and that's a step under the tokens. So most people when they're doing chat, they just take the text, tokenize it, and think, oh, I'm done. I have the token IDs, put that in. No, actually, there's a whole other thing up below that, which is the embedding, and that's floating point. And basically, this spits out the entire embedding, and it does smart caching of that, so it's not completely recomputing it every time because these embeddings get big. Is how it does that all efficiently. Then on top of that, there are plugins built. And this is how you do like the ASR and the TTS and the video streams. And you don't have to use all of this stuff. You can just use the low level model generation API, and you can do live stream VLM and your own video source from that and like 10 lines of code with that. If you want to like reduce your boilerplate, like I was doing a lot of different agents and like copying code around all the time. So I started putting them in these plugins for doing ASR and TTS and video streams and web server stuff. And then they end up getting integrated in like these higher level agent capabilities that you can layer on top. For example, the voice chat one hooks up ASR and TTS to the LLM. The web server one hooks up the web server and web sockets to it. Then the video query one hooks up the video stream and RAG and the database and all of that stuff. So you can like combine these easy without needing to like redo it. And again, like everybody is welcome to do their own agents, and because that's like your application essentially. But if you want to pipe into this and reuse what we already have going, make your own responsive web UI out of it, please feel free to. What I will say is that I do highly recommend using this for the low-level inferencing, and this is how you will get the most optimized performance on JETSON. My next thing to work on is not only buttoning this up, because you'll want to change over from using local LLM to this. It's like literally just changing the container name. The APIs and stuff are mostly the same from there. It's just now the docs and the project organization are much better. But next I will be adding TensorRT LLM support to this, and this will continue to have the most. I basically made this because high-end APIs like MLC, TensorRT LLM, AWQ, like the best ones, they're not in like Ooga Booga or like whatever, you know, they're not adopted as wide because they're not quite as easy to use. But you can write wrappers around them, and they're just as easy. So if nothing else, use this if you need the max performance on JETSON. Otherwise, probably use llama.c++, as Gary was saying. But like, also don't be surprised when it's not as fast. And also, I've been burned by llama.c++ changing the model format all the time. And I was just viewing over the weekend, there's like big drama in that community with like they're changing GGUF again or something, and like yeah. But overall, it's like that's my secondary API that I use to. As soon as I get a new model, I'll load it in Ooga Booga with llama.c++ and try it out that way before I do anything else. So it's still definitely one of my go-to tools. Yeah.
Hey, Dusty, just a time check.
Oh yeah, well we're getting there. I think we're done with like the actual topics that I wanted to discuss. If there's anything else at this point that people want to chat about, I'll stick around for like another half an hour or so. And before, if anybody that needs to drop, obviously, like, sorry, we already ran over by half an hour. Like, I didn't even know how long this meeting was gonna last. How long do you think, what cadence do people think we should do this at? I feel like 2 weeks is probably good, given the pace things move at. What do we feel? Okay, we're getting some thumbs up. We'll do 2 weeks. And like, we're not going to have all this magically solved in 2 weeks. Hopefully in 2 weeks, we can give an update like, hey, yeah, we ran the Wyoming containers, or like we got Piper working a bit, or like Dusty finished the NanoLLM migration and got an early build of TensorRT LLM running, or like everything takes 3 times as long as you think it will. But we can give updates, and yeah.
Dusty, on alternating weeks, and again, this just, I don't know how much time people have to devote to this, but on alternating weeks, could we do a breakout session on one topic in particular?
Yeah, and if you guys want to like have different topics that you discuss next meeting, let's do that. Just post it on like the forum on like what you want to talk about. I will. So how this is going to go from here is I will post the recording of this meeting, assuming it recorded correctly. And in that post, I'll post a link to the next meeting invite. And we can also start a mailing list, so I can just like send Outlook invites to everybody. But it will have a link to like the next invite with a forum thread for it. And if you have topics that you explicitly want discussed in there, just add them, and we can do that. Things, other research things. The ones discussed today, I really wanted to get kicked off because they're important for the long-term roadmap of this like cognitive AI that we're trying to do. But as we know, there's a dozen topics I already have listed on the page, and that list is only going to get longer. So yeah, please feel free to. And this is an open group, and we can discuss whatever we want.
Awesome.
So this is Elaine from C. So I want to say
Elaine, thank you. I'm sorry. It's probably like 1:30 at night. It is 1:30. I'm sorry.
It's 1:30. No,
Yeah.
it's a pleasure
Okay.
to join the
Thanks,
meeting.
Elaine. Yeah.
Yeah.
Elaine's from C.
Yeah.
She's great.
Thank you, Dustin. Yeah, so I want to say like for our for the HomeAssistant project, we're working with Mike and Dustin and also
and let's transition that discussion off of email and into the forum thread that Mike's already replied to. And certain things like with Paulus or like higher level strategic things, yes, we can still do over email. But I think we have Paulus' blessing to like this plan makes sense. You know, let's continue on in that way.
Yes, exactly. So but for our that topic, I say so now Piper is already can work with ESP. So we're also working on a new board we presented at GTC that integrated a camera and the speaker and the screen. So that is we haven't released that product officially, but for everyone in this research group, if you want to collaborate with us on that topic, I mean integrating. The first task is integrating Piper to your container. We're happy to have people try on our new device and to move this task more quickly.
Yeah, awesome. Okay, yeah, let's do that. And another thing we discussed, Elaine, was using. We're not only going to get into Orin Nano, but the Orin NX 16 gigabyte board is actually that's like I feel the really ideal platform for all of this because you can run like all the models in 16 gig. It has more oomph than Orin Nano, and Seed Studio makes a really nice recomputer box for $899 that has the Orin NX in it. And I get it, like none of this stuff is super cheap, but if we can show that like, hey, we have a fully cognitive AI that can like learn everything about you and like help you in your everyday life, that's like not too bad, considering like the alternative is like people are buying much more expensive desktop systems, Mac Studios, whatnot, with these higher end cards to do all of this stuff. And if we're able to bring that down to like under like $1,000 that you can fully outfit it and get like a really intelligent personal assistant integrated into your home and daily life, I feel that that's like pretty compelling for like your early adopters to go off and start messing around with.
Exactly. Thank you, Dustin.
Yeah, obviously we always strive to like make things as inexpensive as it's like the accessibility thing, right? And eventually all this will like just be on your phone and you know you'll be able to do VLM right from this. And that's another cool thing about that MLC API is like it does web GPU and runs on mobile devices too. You can do mini LLMs on your Android through it, and it's really great to have all this be prevalent throughout. So it'll be certain applications for certain things. JETSON, I always do remind people, because this comes up on like Reddit or whatnot, people are comparing JETSON AGX 64 gigabyte to the Apple M2. And I gotta remember like, JETSON, it is an embedded system. It's meant for edge deployment. It masquerades as a desktop, because you can use it as one. You're gonna run into more hiccups because it's ARM architecture and constantly recompiling stuff. But yeah, it's meant to be like deployed out there in the real world, and we'll see in like a couple of years. I think you're really going to see a lot of things come to fruition like this. And because part of why I'm like really loving this whole process is we already kind of went through this with the original JETSON Nano, and at that time it was getting everybody started with like CNNs and doing their fine tuning that way. And it was a massive success, even though like everybody took a while to like retool and learn the new way of doing things. And even now it's like my grocery store right up the street has like a shelf scanning robot rolling around with it. I Googled the thing, it has a JETSON Nano in it that's running. I was like, wow, like probably running some of our own GitHub code right there, and the whole circle is like just completes itself. And this stuff does take some while to like trickle down into like production and to the point where you'll see like robots and humanoids or whatever on the factory floor out there in everyday life. But like it is, I think we all know now that we're confident that it will happen. We just need to like keep pressing on, keep pushing forward, continue. And that's why I want to do this research group, man, because like there's all these things, we have line of sight now to getting there, and it's possible. And I think what's so exciting about it is the almost like limitless potential of it and these workflows, the ability to like train them to converse about whatever that you need them to. So it's super exciting, and I thank you all for wanting to be involved and work together to essentially get there faster and do so in an open way that is able to be leveraged by everybody in the world for the benefit of everybody. All right. If there's any more questions, I'm happy to stick around and chat, but I understand you guys gotta drop off. That's fine too.
Well, thank you, Dusty. This has been awesome.
Yeah, thank you.
Thank you, Brian. Shakazat, did you have a question, buddy?
Dusty.
Yeah,
just
we'll do
one
this again in
small
2
question.
weeks. Yeah, what was it, man?
About TensorRT LLM.
Yeah.
If it's going to outperform MLC LLM.
I don't think it is. It may. They're like neck and neck right now. And this is something I tell people, like, don't keep holding your breath for better performance on ORAN, because as part of like the internal I spent a lot of my time, and I still will continue to, just the core inferencing and optimization part. And this is really why I need you guys. Like I'm happy to continue focusing at that lower level and give everybody the capabilities that they need to go off and build this stuff out. But it's like a full-time job just on its own, keeping all the inferencing stuff running well. And yeah, I really need your guys' help to go off and do this higher order stuff out there and contribute back, so we can all leverage that. But yeah, so part of our optimization thing was getting the chip arch guys involved, and they have high-end like simulators and stuff that'll tell you exactly what the chip is capable of, and for like such and such algorithm, and you put llama architecture in there, it says, okay, AGX ORAN with such and such memory clock speed can do a max of 50 tokens a second on Llama 7B. We're at 47 tokens a second. Okay, so like we're good. We can. There comes. Transformers are very memory bandwidth intensive, right? It's bandwidth. It's simple mathematical calculation, really, how much memory bandwidth you have available and what you can do there. And it turns out 50 tokens is like the max on that. And so like we're already good. That isn't to say there aren't different optimizations for other models. I know one thing Johnny's looking at is like these new recurrent models. Mamba has gotten more traction even within the past couple of weeks. So Johnny, if you like want to make that your thing and you start looking at whatever the next Transformers is, because that's going to be something that will continue coming up, and we want to make sure that we're optimized and ready for that. I know MLC, they do recurrent models, they do RKVW in that, but yeah, I mean, I agree with you, Johnny. The Mamba and this other newer Mamba on top of it, those are starting to pick up steam actually, and you can kind of understand how first there was CNNs and they were all the rage, and we thought, wow, this is like amazing. Then Transformers came along, which was not instant. Like we did BERT and stuff for years, and it was like, these are cool, but it's not like revolutionary per se. It's still limited NLP. Then all of a sudden something happened. Llama came out and it was like, whoa, right? But you can see how that pattern could repeat, and there will be some other future architecture that comes out that could be just as transformative again. I don't know how long that would be from now, but we want to keep our eyes and ears open about it. So, but yeah, Shaka, the TensorRT thing, it's less about perf and more about compatibility, official support, production grade software, stuff that's not just like built off of Dusty's GitHub, although ironically I'm the one that's going to be building it still. But yeah, and it's also to like leverage the other like NVIDIA NeMo models, the NIM microservices they're putting out. Because like NVIDIA obviously has a whole lot of like enterprise stuff going on with like their containers that are like servicing like billions of queries or whatever, that's like really high end, and we want to be compatible with that. And also like it's a real benefit. The TensorRT LLM team, they work with all the biggest companies before models are released to get some day zero support in there. So like with Gemma, they had support ready like the day of, right? And it turned out not to be a huge deal for Llama.C++ and MLC because it was added the day after. Okay, so like it's still fine, but you can see how maintaining this edge to cloud compatibility is important. And I can see how, Shaka, that you would be into that because you also do cloud systems and have DGX and like want to be able to run TensorRT LLM on there and also deploy it to JETSON. So that whole story is important. And just overall more, like I've learned, it's good to not put all your eggs in one basket. Like I've been burned on relying too much on one TTS and like there's been bugs in it or it goes down or wait for a new Jetpack version to come out and then you don't have TTS. Well, we should have backups for each. I feel like we should have really two high performance model APIs for like everything. And then we're good. Even if there's some issue that comes up, you can fall back to the other one. And that's what we'll have here. Yeah. Let me see who else has their hand up here.
Thank you.
Ashwin, you have a question. It might have been from before. I'm sorry.
Super insightful. I'm a recent, I've recently come across the JETSON AI group, and I just had a question about, yeah, absolutely. Thanks for everyone for hosting this. I heard your comment in the beginning about how a lot of this is being driven from some people on the silicon side, and then some people on the AI scientists on kind of like
I was just speaking to like who's actually making this all happen for us to be able to like take advantage, because this is all like a dream to me. Many of us in this group, we've been at this for decades or more at this point, toying around with like basic OpenCV on the JETSON TK1 and like someday we'll have like actual robots, and somehow we're like actually getting there, and like we are collectively all the guys and gals to do it, and it's just really amazing. But yes, I do want to give attribution to like the people that design the amazing silicon and train the amazing foundational models. We are benefiting from their work.
Yeah, absolutely. And I'm one of those guys who's been working on older renditions of the JETSON and integrating small level features and things for many years now, right? So
yeah, thank you for sticking it out through all the years. And yeah, I know there's pain points there.
Oh, no. It's been great. My question is geared towards people like me who want to get involved in the community, kind of integrating some of these models to run on embedded devices. I'm an embedded software engineer, so I'm just wondering, what's a good place for us to start? Can we like peruse the forums and see where we can get involved?
Yeah, and if you have some models in particular that you already have in mind, then great. Feel free to like. You've already been around a while, so you already probably know all the CNN stuff and all that. You can, if you haven't yet, go through the tutorials on JETSON AI Lab, the ones you're interested in. That'll give you a better feel for like how this whole system that we've architected works, where it's like underneath JETSON containers, GitHub is set up with like all these Docker workflows and everything so that the containers are automatically built. Inside those Docker files, you'll find all these patches and compile flags to make these packages work with CUDA. And then there's all these tests and benchmarks to make sure the performance is really what you need it to be. And then from there, you can submit a pull request against JETSON Containers GitHub. It will then be added to like my build farm here, automatically go out on Docker Hub so that everybody else can pull the images. And what's important about that is anytime one of the underlying packages changes, it will then recompile yours. So like, let's say there's a bug in llama.c++ or new llama.c++ comes out and I push the update for that, it will then recompile all the downstream packages for that too, push those updates to GitHub or to Docker Hub automatically. So that whole system does the work of like a whole team, and that is why I recommend people like integrate with that, because it'll just make your lives easier. But if you have anything particular in mind, like you just post that like JETSON projects forum to like get a discussion going, or like right now, the models that we're looking at are these lightweight ASR and TTS models, because that's like our focus for the time being. But that always like constantly changes. Johnny's been asking about the recurrent LLMs and stuff. I feel like on like the traditional LLMs, we're like pretty good for now. Those seem to have stabilized around architectures like Llama, Stable LLM, Phi2, Gemma is new, but like everything's a fine tune of that, okay? And so like, for example, Vicuna or Alpaca, we don't need special support for that. We already have Llama optimized. And it turns out all the Lava VLM models, those are just Llama derivative also. So when I say we're getting that 47 tokens a second on Llama, that means for all Llamas. And that's very important because different model architectures do have different performance characteristics, such as Mistral. They have sliding window attention, other things in there. Not all LLM architectures are actually built the same. And but Llama by far is the most optimized one, because that's what everybody is using pretty much. I do have a short list of mini VLMs that I need to try and get to. For example, there's one called Bunny. Then the Bunny one's pretty popular. Just one came out from, I think it was Microsoft did it just yesterday via Lava Gemma, or it was Intel. They did Lava Gemma. That's a good one to try. Their Moondream. There's like a bunch of the VLMs can require a little more support in them than the LLMs. The LLMs are basically just like run it, test quantization, and it should just work, get the chat template going. The VLMs can require a little bit more finagling because they also have the vision encoder in there too, which is another point to bring, that expanding vision encoder model support. Like right now I support Clip and Siglet, and I believe, like I've tested exporting those to TensorRT. Right now they're just running in PyTorch FP16 because they represent a very small portion of the pipeline. Like less than 5% of the pipeline is spent in there. So I haven't really even spent time like putting Clip into Onyx runtime and running it that way. But I believe you can, because I exported to Onyx and ran it through TRT exec, and like it'll run in TensorRT. I just like haven't gotten there. If that's something you want to look at, that would be great. But whatever like motivates you guys to work on and you're interested in, please like work on that. Just like keep the group updated or like contribute it back on GitHub. Let us know like the code that you put out, or like I'm happy to help on the infrastructure side, like adopting the stuff that you guys make and like capturing it for the group so that everybody can leverage it. Obviously, one reason like the JETSON AI lab has been successful so far is because it's a common place that everybody can go and just like get the containers, get the models. These tutorials are easy to follow. We can go from there. So, and the JETSON containers, that's just a GitHub IO page with Markdown on it. You can contribute new tutorials to that very simply and do pull requests against the JETSON AI Lab website too. And we'll just build out this content more and more for people. But I do feel it's important that we support each other's work and are able to share those learnings and communicate those through the forums, these meetings, the tutorials on GitHub, JETSON AI Lab, and Hackster is good for hardware-based demos too. But yeah, people are going to have to start writing documentation, and I get that. It's nobody really likes doing that, but it's very effective at getting people's work shared with others so that it ends up integrated into the next phase, and eventually it's put on there in the robot or smart home sensor, and yeah, without the docs that nobody knows how to use it. Let me see. Any other questions? Not, I'll let you guys go. Ashwin, Shushan, if you had any more questions, feel free to holler.
Hi, am I audible, Justin?
Yes, we can hear you.
Yeah, so I want to know, like, are there any scopes or like thought process on integrating like 3D reconstruction models like pointy, Gaussian splatting, Splatam?
Yeah, that's
because
a great
I'm particularly
question.
interested in trying that out.
Yeah, and it does speak to a higher level thing we're going for, which is like that stuff is in Isaac Ross, NV blocks. Okay, if you haven't Googled, and there's whole other reams of work NVIDIA is doing in Isaac Ross on like really high-end robotic perception, navigation in ROS 2. We're on the ROS 2 steering committee. Like the robot stuff and like actual autonomous systems, those are going to happen. We are the ones like they're doing all the LLM and user integration and UI stuff. With that, they're much more on this like more traditional high-end computer vision, DNN based pipeline still, using like simulation technology and stuff. And those have 3D reconstruction in them as well. And I don't know if they're like the Gen AI based models that you're talking, like NERFs and stuff. Is that what you mean?
Probably Gaussian splats because they are way faster. So like when
it could be
takes an hour.
And and like if you want to work on that and get it running well on Jetson and put a tutorial on the Jetson AI Lab for NERFs or whatever, that would be great. And there's another similar thing for like this diffusion model based image processing. Okay, that is a cool thing, and we do have some initial projects on the Jetson AI Lab from the community that have effectively utilized diffusion models for like image enhancement, and it makes a lot of sense when you think about it. Like they do image to image, so of course it's going to be able to manipulate images too. And I feel like I don't have the bandwidth to even look at that. Katerina, she's from NVIDIA, located in Europe. She's used Jetson for a while. She knows about using diffusion models for that. And so yeah, and if anybody's interested in like branching out into whole other realms, because like we don't even have the time to, that's a big part of why we need this group, right? Is the pace of things is so fast, literally it's impossible to, even if there were 36 hours in the day, you would never be able to keep up with everything. So yeah, I would love it if you can get this stuff running well and optimized on Jetson. Would love to take contributions for that on the site. And like with the Jetson AI Lab docs site, like you can have your own GitHub and like have it documented there, and then do like a higher level blog post or summary on the Jetson AI Lab. One thing about like the documentation I spend so much time on is because there's so many levels of it. Like there's a low level reference doc, there's your GitHub README, then it eventually transpires into the Jetson AI Lab tutorial that like anybody can follow, you know, and then there's like a YouTube video on top of that. So it's like a lot, but eventually everybody ends up knowing how to use it, and it's very effective at teaching others to do it.
Sounds great. Thank you.
Well, I'll do a quick plug for mine because my open source project's about to come out.
Okay, awesome, Chris.
And I do have a whole website of documentation. It's one of the reasons it's taken a lot longer to release the code. So if you're interested in wearable technology,
and we are, because like your thing, even though it's super awesome, and you have to give the group a demo of it at some point here, but it's akin to like the blind assistant devices or whatnot. These wearable tech is big, and like I understand that might not always be deployed with Jetson down the road. It might just be run on your smartphone. But like part of this is like prototyping these systems, and like at GTC they had, I think it was Lucid or Lutron or somebody, they had an actual blind assistant device with a nano form factor module running in there that was doing like real-time segmentation, vision to speech for blind assistant people that could do OCR and like tell them if they're walking into like the road or read shelves in the stores. And it was amazing. And the other cool thing that they told me was like, yo, 5 years ago, we got started on your GitHub tutorial about doing all this. And here we are now with this blind assistant device going out and like helping real people using these high-end models. And it was like, yeah, this is what it's all about. This is why we do this. So I appreciate everybody that's involved.
Sorry, is it Lumen product?
I think Lumen was Lumen might have been a LiDAR. Lumen. Hold on. I'll look it up. I don't think it's Lumen.
I've put the link on the chat.
Oh, thanks. Yeah.
And I also wanted to highlight we have a case study about them on how they're using Orin and Isaac Ross.
Okay.
I'll put that also in the chat.
They are really cool. And there's lots of like really great applications for that have good, great humanitarian impacts, ecological impacts. We got to remember, like, we're doing this to like improve the direction humanity's going here. So we're collectively the group that's pushing things out there to the edge and has this ability to bring these technologies into the real world and really like have an impact, even though it can take years to deploy embedded systems like that. Downstream, it has a big impact. And I think a few years from now, we'll be looking back on this and be like, wow, we all banded together and made that all happen. So, okay. Unless there's anything else, thank you everybody for sticking around for 2 hours. Probably like later tonight or tomorrow, I'll send out another invite along with the recording of this. We'll do it again in 2 weeks. Hopefully that will be a shorter meeting of a status updates and any new projects people want to discuss. We can do that too. Post your topics you want to discuss to the forum in advance and we'll add them to the formal agenda. But yeah, this was awesome. Thank you guys so much. We're totally going to keep doing this. And within the next 2 weeks, if you want to get involved and hop in on stuff, please do. And hopefully by that time we can report some progress being made on these things. So I'll let you all go. Thank you so much.
Thank you.